Anyways, I was.
Good morning to you all. Good morning to you all.
Good morning. Good morning, sir. Morning, sir.
Morning, sir.
I'm confident of decisions. Today we have. I want to start GG103 with you, and the topic we are to treat is kinematics of particles. Maybe before I start, let me. Okay, as time goes on, I will send you the topics that I will take from my side. Dr. Folonso will take the other part of it. However, this is mathematics. It is not something you read like a novel. You have to practice and engage. Yes?
What is your name, sir?
My name is Rahim Adewale from Systems Engineering. Rahim WA from Systems Engineering.
Okay, sir. Thank you, sir.
So with time when we do physical, I will get to know you guys better, at least facially. But now you add my name on the platform and I'm the one speaking now. I'm not going to use the entire time. So because the two of us will take at least fragment of the parts that each one will take. However, your maximum attention is required for your own good. Number one is that at the end of this class, these 4 things listed, you must be able to evaluate it. You should be able to explain it. What are those things? ILO mean intended learning outcome. That is, at the end of this class, you should be able to discuss to understand what exactly is called dynamics. And dynamics is just divided into 2. Kinematics and kinetics. Kinematics is the area of our interest today that we are discussing. And another thing that you should be able to understand and explain is rectilinear motion and curvilinear motions at the end of the class. Then the third one is you must be able to evaluate acceleration as a function of time, acceleration as a function of position, displacement, and as a function of velocity. And the last one is relative motion. So at the end of this class, you should be able to evaluate yourself, assess yourself on each of the 4. Which one am I lacking behind? It's advisable you don't deceive yourself. Where you think you have issues, go and consult. Consult textbooks, consult internet, consult your friends, and ask questions in the class. Bear it in mind. Ours is to facilitate, show you the direction to go, the limit and the range of what is expected of you. Library is there for you to catch up. So what is kinematics? I've explained from the last slide that the body of knowledge there is called dynamics, which is divided into kinematics and kinetics. What is kinematic all about? is nothing but the study of geometry of motion. The relationship between displacement, velocity, acceleration, and time without making reference to the cause of motion, that is kinematics. But kinetics is just the relations between the force or forces acting on a body and the motion of such body. So you see that kinematics has nothing to do with the causes of motion, only the relations or relationship between displacement, velocity, acceleration, and time. However, kinetics is centered on the motion of a body and the relationship between the forces and the body or the mass of such body. So you see the difference. So we use kinetics to predict or forecast the motion caused by certain magnitude of force or forces in order to determine the forces required to produce a required motion at a point in time. Because at times you may need the motion to be fast or faster or slower. Something must be responsible for change in those motion. These are what kinetics and kinematics is all about. Then when this motion that we are now talking about in both kinematics and kinetics, the motion could be on a straight line. If it is that, either in a positive direction or the negative direction, we call it rectilinear motion. And from the word curvilinear, the position, velocity, and acceleration of any particles or body that moves along curved line, either in two-dimensional or 3 dimensions. That is what curvilinear motion is all about. So you see that this slide alone has given a little introduction to the first 4 ILO, to the first 3 ILO out of the 4 that we mentioned, that at the end of the day, you should be able to describe, to explain, and to evaluate any problem given to you than that. Now, this is an example of a rectilinear motion. Look at this, my caution. The movement from, look at this, is 0 to P to X is on a straight line. But look at this, the second one, this second one on a curve. What we intend to do with this curve, this graph, ST curve, is that the position curve is that we may need to evaluate the time at every point in time. That is what we are trying to do there. And when you see this curve, we can evaluate the time, the movement at every point in time. At different time, we can evaluate that. You have any question regarding that before I move forward? Before the class,
explain it again, please.
from which part? Is it like rectilinear motion?
Yeah, the rectilinear motion.
Rectilinear motion has to do with position, which is displacement, velocity, and acceleration. And as I said, is a movement in a straight line. An example is the first image that you can see my cursor there, and you see how it is being calibrated from 0 to P to X. The movement in that direction is rectilinear. But this position time graph that we have, when the particle moves from a 0 down to 32 to any height before coming down, we can use the knowledge of rectilinear motion to evaluate at point in time of displacement or position, what is the time? Then at what time the movement of such particle is at what point? Those are the essence. We can evaluate, use this, the knowledge of rectilinear motion, to evaluate both the time or the position at any given in time. Look at this mathematical relation. If we say x is equal to 6t square minus t cube, x is the position. So we can find t when x is maybe 10 or 30 or 50. That is the position. When the position is at this point, what are the time? We can reverse the evaluation. If we have the position to be 60, or if we have the time to be 7, what will be the position at that point? Or if we have the position to be 30, what will be the time at that point? That's the essence. Is that clear or any other clarification needed? Can I move on?
Yes, sir.
So also
Sir,
we have
sir, sorry, sir. Sir, can you come again with the X?
with the x.
Yes, sir.
Look at this graph. Is the position time graph. X
Yes, sir.
versus time.
Yes.
And you see the movement of particle in that color. Is it blue?
Yes.
So if the movement of that particle, let's say the position is at 10, you see the 10 here. What will be
Yes.
the time? What will be the time at that
Mm.
when the body movement, the particle is at position of 10? What will be the time at that point? You can
2.
evaluate it. Now
Okay.
look at this. If the movement is at 24, what will be the time? You can use the graph
3.
to evaluate it. So, and you can use the mathematical relations, this mathematical model, x
Yes.
equal to 6t square minus t cube. From this, we can solve in positive direction or in negative direction. For instance, let's assume if our x is 30, what will be the t? That is the position. Look at this graph. If it is 30 here, what will be the t? So you can evaluate here. And we can
Okay, sir.
evaluate in the other direction. If our time is 50, for instance, what will be the position? So
Okay,
that is
sir.
what we mean. And this one and this is talking about what we call instantaneous and discrete. Let me ask you a question. When you hear instantaneous and you hear discrete, what is the difference? Example of the instantaneous is when you have like this, delta phi over delta t as limit 10 to whatever. That is instantaneous. But when we have discrete, you have dy or dv dt, dy dx. That is discrete. So what is the difference between the two? Who can tell me?
Sir, please, so sorry. Please, can you come again with the instantaneous and the discrete?
I said when you
I think
hear, oh yeah, go ahead.
I think discrete is talking about the change in time, like how the position changed the time. Maybe it is how the velocity changed the time. And instantaneous velocity tells us the exact time at a particular moment, at the exact velocity at a particular time.
Thank you. Any other opinion?
So,
Go ahead.
okay. So I think that the dvdt is explains the rate of change of velocity with time at any particular time. Probably there's a formula for it at any instant of time. At any particular time, you can input that time that you want into it and get the formula for the answer for the acceleration. But this one is saying at a specific time, like after 2 seconds of the motion, like in motion, after like 2 seconds after the motion has started, this is the acceleration at these 2 seconds, at these 3 seconds.
Thank you. God bless you.
So,
Amen, sir.
so,
Yes, yes.
so I think instantaneous is the the position of the body at a particular time. Why for this case is what the the position of the body at two time interval at a time interval. Yes.
Thank you. All of you, you have idea of what we want to drag out. But let me give one practical example. If I say Gavar or let's say Rahim, how old are you? If Rahim said, I'm 20 years old, that one is discrete. And that is dv dt. At exact t, what is v? The change in velocity at that time. So that one is discrete. But for instantaneous, if I say Rahim, how old are you? And Rahim says, I'm 20 years old, 1 month, 5 days, 7 hours, 2 seconds. You know, understand that one is instantaneous. And that is the reason why in every instantaneous, you will see that they will put one condition, limit as x tend to 0. So it means before x getting to 0, at x equal to 0.9, what is the subject matter they are requesting for? At x tend to 8, 0.8, 0.7, and so on. So that is instantaneous. It also can be evaluated on rectilinear motion. This example of what we did the other time, the position time, you see we use the same. And if we say x is equal to 60 square minus t cube, we want to find velocity, we can find acceleration there. So that's the next stage that I said you should be able to evaluate acceleration as a function of time, acceleration as a function of position, and acceleration as a function of velocity. So this practical example, but let us look at this one. When you want to find acceleration as a function of time, our dv dt equals a acceleration. If you find that one, you find acceleration from dv dt, then you are evaluating acceleration as a function of time. And from this dv dt equals to a, which is a function of time, you can also find the v only. Just make the v subject of the formula. And if you want to find the velocity itself, note the v is change in velocity. The v means v2 minus v1 or v final minus v initial. So you just integrate. And while you integrate, you introduce integration sign with t from final, you set the range, boundary conditions. Then you get change in velocity equals to integral of change in time dt. So you can evaluate from the positive side, from the v dt equals to a equals to f of t. And there might be a need for you to evaluate from v of t minus v naught equal to integral of, you can evaluate from that difference in velocity equal to integral of function of time dt. So you can evaluate from either both sides, either from a positive direction of the reverse is the case. And so also you can still also evaluate acceleration as a function of position, which is a equal to f of x. And when you want to do that, velocity is equal to dx dt, or dt is equal to ds dv. You don't need to cram, you need only this first one. You just do the subject of formula, change the subject of formula, and you get dt equal to ds over dv. So also a can be dv equal to dt, or a v dv v dv over dx equal to function of x. So also, if you now want to find the individual constituent, you want to change the dv dx to v, either final velocity or initial velocity. You introduce the integration condition. When you integrate, you get this one. So what we want to take out from this is that there might be a need for you to evaluate from dv dt equal to a, or v equal to dx over dt, or v dv as equal to function of x dx. And there might be a need for you to work from the reverse, from the result to the answer, or from the answer to the result. When we get to one or two work example to understand more better. The last part of it is yes.
So I thought if we differentiate velocity, we'll get displacements. And if we differentiate acceleration, we'll get velocity.
Look, when you differentiate velocity with time, you get acceleration.
Yes.
When you differentiate position with respect to time, you get velocity.
Okay.
Don't mix it up. So
Okay,
when
sir.
you go, so that is exactly when you now integrate it, you integrate the x.
Yes, sir.
Then it is then you get velocity.
Okay.
So that's you see this slide you are seeing, and the second slide 8 and 9 summarized everything. Boluwatife Isaac,
Thank you, sir.
you raise up your hand, yes. Boluwatife,
Yeah, good morning, sir. So,
good morning.
sir, I just want to ask you, will the slide and the video of the lecture be available after the class?
Yes.
Okay, thank you, sir.
So the last part is when you want to evaluate acceleration as a function of velocity. So that is when you differentiate the v dt gives you acceleration. And you can introduce integration also to get time. That is what we did here. You can do it, you can evaluate from dv dt equal to a down to this side, and you can evaluate from this integral of v dv over f of v, you will get dv dt, or you will get the acceleration, subject to what exactly are you looking for. Now, let us look at this example. A ball tossed with 10 meters per second vertical velocity from window 20 meters above ground. Determine velocity and elevation above ground at time t. Another question, determine highest elevation reached by the ball and the corresponding time. That is the position time that we showed the other time. What will be the time when the particle is at this position? And the last question is, find time or determine time when the ball will hit the ground and corresponding velocity. What will you do? The solution is that you integrate twice to find velocity and y. Y is height. Then you solve for t, at which velocity equals to 0. That is when the time for maximum elevation. When the velocity is 0, you know, it must get to 0 before it starts declining down. And you evaluate corresponding altitude. And the last thing to do is you solve for t, at which the altitude equals to 0. When the altitude equals to 0, then that is time for ground impact. That is when the ball will hit the ground. I'm coming, okay, Fewina. You can now evaluate the corresponding velocity. So this is the solution. Look at this graph. The window is at the 10 and it throws the ball. So this is velocity time graph, because this is the velocity and with respect to time. So dv dt equals to a. Our acceleration to gravity there is minus 9.81 meter per second square. Who can tell me the reason why our a is negative?
It's decelerating.
Because it's against
Because
gravity. The
it's
direction is
going against
against
gravity.
gravity.
Because the direction is
Direction,
the direction is
then
negative.
Yes.
because direction is negative. So when you now have dv dt equals to a, and your a is what you are given, minus 9.81, how will you get the velocity that you want? So look at the last slide. So we now introduce integration to dv, and you get introduced to both sides. When you introduce integration sign to both sides, then you integrate dv and you integrate the a, which is minus 9.81. You just send arbitrary range, that when time is t and when time is when velocity is final and when velocity is 0. And for t, when time is t and when time is 0. So v of t minus v naught equal to minus 9.81 t. That is your velocity. And you can just say v of t is equal to, we change this. And you know our initial velocity is 10. So we have 10 minus 9.1 t. Lawa Ibrahim,
Yes, sir. How do you get the V naught?
v naught
Yes.
Our phenol is 10. Look at the question.
Okay, so the
Ball
question, don't
toast,
worry.
ball toast with 10 meter per second vertical velocity. That is the phenol. Any
Thank you
other
very much,
question?
sir.
You're welcome. Afolabi Tosi.
Okay, sir. I see that in the equation they were using the units like meter per second, and most times when we're solving, we don't put the units. For this particular course, do we have to put the units when we're solving towards the end, just so we can proceed?
Thank you. Thank you. You see, the reason why we put, please tell those people that if you want to talk, just mute yourself so that you will not disturb others. The reason why we put the unit there is that you will not get confused. If you don't put unit there, you may not be penalized, but it's advisable you are very conversant of that unit, because the question may have certain constituents given to you in meter, while another dimension may be in centimeter or millimeter. If you are writing it there, you will notice the inconsistency and you will quickly change to uniform unit. But if you are not careful, you don't put it there, you may end up using meter and millimeter and centimeter together. And that inconsistency will not allow you to have an appropriate result, though you will follow the same correct concept. But when you change it, you will notice it and use the uniform unit. That's the reason why. Isaac Oluwatobiloba. Isaac,
Okay, sir. I want to ask that, sir. I want to ask that for this kind of question, can't we simply use equation of motion?
you can use equation of motion and you will get it. But remember what we are discussing. That equation of motion you are talking about is still under rectilinear motion. But if the question, look at the way the question is structured. The v dt has been given to you to be, no, A has been given to you as minus 9.81, and you know your V naught. From where we started, that you can find you can find acceleration as a function of time, or as a function of position, or as a function of velocity. If the question is in that direction, there is no way to do it to get it appropriate than to sketch the diagram and to do it in this direction. But if the question silent on whether you are finding the acceleration as a function of whatever, you can use any means and you will get your answer. Masood.
Okay, okay, sir. Yes, sir. Sir, what I don't understand is that the last expression you explained, I don't really get that expression. Where you said integration of the v equals to minus integration of 9.81 dt. So I don't understand how you came about the v as a function of t minus v o equals minus 9.81 t. I don't get
Now
it.
look at the v dt equals to a, and our a is minus 9.81. Just
Okay.
cross multiply to have the v equals to a dt. When you have the v equals to a dt, you now introduce integration to the both side. You now integrate the v and you integrate a dt.
Okay.
You set the boundary to be final velocity, which is v of t, and initial velocity, which is v naught. Then where we have t, you have t and t is 0. So by the time you integrate the v, you have v of t minus v naught. By the time you integrate a dt, you have at, and our a is minus 9.81, then t. That was what I said. Now you just collect the lifetime because you are looking for v of t, which is the final velocity. You just take v naught, negative v naught to the other side. And our v naught from the question is 10. That is how we have this one. Is it clear?
Okay, sir. Yes, sir. It's clear, sir.
Rahman Jubril, your question.
So I just want to confirm the V naught is the initial velocity, right?
Yes.
Okay, sir. Thank you, sir.
Marvelous Oyeniyi, your question. Marvelous. Masood, if you don't have any other question, please put down your hand. Marvelous is not there. Then Jayesimi Ifeoluwa, what is your
Sorry,
question?
sir, I'm here.
Your question.
Sorry, sir. Sir, when you integrate 9.8 dt, sorry, sir, how did you get minus 9.8 t?
How did I get minus 9.8?
Yes, sir.
Is that your question?
Yes, sir.
Thank you. Can somebody explain to me how did I get minus 9.8 t?
When you integrate a constant, it's going to have the t. Like on it, the acceleration due to gravity. So once you integrate a constant, it's going to be equal to negative 9.8 t.
Is it clear?
Yes, sir, it's clear. Thank you, sir.
Look, I don't understand.
So any other question?
Excuse me, good morning, sir.
Oh yeah, go ahead.
Sir, please, how did you get the minus 22.2 in the diagram on the slope?
Minus 22.
22 minus 22.2 meter per second. How did you get it in the diagram?
Okay. You add, when you will finish, you will see how we got that 22. Initially, when you just draw, just assume this is a 0 and you draw down. But when you evaluate further, this diagram has addressed some other things. You see 3.28 there, you see 1.09 there. We have not gotten to that.
Okay, sir.
What we know is that we have time, velocity, time diagram, and the initial velocity is 10, and when you throw it, it reach the ground. The image of the diagram will be like this, but you may not get any value except the 10 and A, which is minus 9.81.
Okay, thank you, sir.
So when you continue your evaluation, it is then we get all other values. So for the second one, the V dt is equal to velocity. No, we have gotten velocity here, which is 10 minus 9.81 t. Now, here is our y. We now want to find velocity with respect, we have unknown here. We don't know velocity because we don't know time. But now we want to work around how to get the time. And in order to do it, because when you look at the question, Find the highest elevation reached by the ball and corresponding time. What is the elevation? This is the height. Look at the diagram. And our height is 20. I mean, our height is 20. Our phi naught is 10. Is given here. Our A is minus 9.81 and reach the ground. So that is the question 2. And what we do is this. Find the y dt, since our y is the highest elevation. So the y dt is equal to v, and our v is this one. We just substitute. And when you substitute, after the substitution, we introduce the integration sign. We now have the y equals v dt. Then we integrate the y, we integrate our v dt. Exactly what we did up, and we get yt minus y naught equal to 10t minus this, and that is our y, our highest elevation. Then we now move on. We now want to solve for t now, which is the time when the ball hits the ground and corresponding value.
So I have a question.
What is the question?
Sir, in the second slide, like how did they get 1/2 in the second slide?
Is this place? Is it this place?
Yes. In the second slide, yes. How did they get 1/2?
Who can explain that among you? Somebody should explain that.
The integration of
Um,
0.81 t. When you integrate, if you have t and they say you should integrate t has an invisible power of 1. So you add 1, and then whatever you add into the power, you divide that same variable by it. So t raised to power 1 plus 1 divided by 1 plus 1. That's the same thing that happened here. 9.81 plus 9.81 t raised to power 1 plus 1 divided by 1 plus 1. So 9.81 t squared divided by 2. So they just brought out the 2 as a fraction to the front of 9.81 t squared. That's all.
Thank you. Is it clear?
Yes, sir. Yes, sir.
Thank you. So we now want to solve for t when velocity equals to 0. Who can tell me why the velocity equals to 0 there?
Sir, because
at
at
its
the
highest
maximum
point.
height, the velocity is always equal to 0.
Because the velocity always decreases as the acceleration is negative, as it's going up.
Because you are asked to find time when the ball will hit the ground and the corresponding velocity. When the ball hits ground, what will be the velocity?
0. That should be because it comes to rest.
maximum.
So when you know velocity already, you just equate it to a 0 and you find t. You now have 10 minus 9.81 t equal to 0. So that is how we got t here. Somebody that asks how we got all this value 1.219, 3.28, 22. You can see how we are getting it one after the other. But at the initial stage, you may not put any value there. Just sketch the diagram and give the value given to you. The initial velocity is 10, you put it there, and it is 0. Just extend it and leave it there. By the time you start evaluating, you now get all other value. Now, when the velocity, the ball hit is 0, hit the ground, the velocity equals to 0. Then we find the corresponding altitude there, which is the height. So V is equal to 0, and we know our V of t, which is 10 minus 9.81 into 0. We got t. So also we find for the altitude equals to 0, and we find when our altitude is 0, what is our velocity? And that is what we did here from what we have before. Also, Abi, what is the name? Osa or Yusa?
Can you
Is
explain
it
more?
Yusa? Okay.
Can you
Oh yeah.
explain more on the graph?
Can I
Please.
explain more on what?
On the graphs, please.
On the ground.
Graph, the diagram.
Okay, on the diagram. No, somebody will explain that one for us now, but let me advise you. Most of you, when you are in a official meeting like this, it is good to use your name, or so that people will take you as a responsible person. Because if it were not to be the class now, if it were to be more official meeting, somebody bearing user, they will just send him or her out because nobody can identify him or her. Nobody bears user. So look at somebody called Masoud, Linus Udeji, Wasiu Rahim, and so many other things. You will be able to call the name. So I advise you to use normal name, even if it is first name alone, than user. Now, Linus, your question. My whole question is that I want some. Oh yeah, I'm listening.
Please, can you explain that second part, so for t at which at t equals 0 and equate corresponding velocity? Can you explain it again?
Now, Lawa Ibrahim, what is your own question? I've heard you on Linus. Lawa Ibrahim.
Sorry, sir. I don't like. I don't understand. You get t equals to 1.0197 seconds.
You don't know how we got that one.
Yes.
Anyway, there are 3 questions before me now. Question number 1, I should re-explain the diagram. Question number 2, how did I get t equals to 1.019? What is the third question? I should re-explain the last two, how v equals to 0 and how y equals to 0. Those are the 3 questions. I need somebody to do the first one for me. Who will explain the diagram? Who understood it?
So for the first diagram.
This is the diagram. This one is the diagram he's talking about.
Okay, I think that initially.
Can I show the question back? Or you don't need it?
I'm explaining the first question, sir. I want to try to explain.
You want to try to explain, okay, please?
So the points on the graph will be given initial values. Like since the velocity is the y value, we're given as 10. So first of all, impute the first value that we're given. And as we solve the questions, we get more values. Then we can put it in a point. Like for example, we got t value 1.091. It's going to be on the x-axis. And as we solve for more values of the velocity, we can now increase it in the graph. So initially, when we're solving at the question, we just sketch the graph. Then later, when we get more values, we can now increase it in the graph.
Thank you. Is that one cleared? Now, I need somebody to explain how we got t equals to 1.019. Also.
So the v point at maximum points, the velocity is 0. So when you input that into the equation, you can just make t the surrogate formula. So you bring 10 to the other side, then you divide by minus 9.81. So you get 1.019 seconds.
Thank you. So who can explain the last question? How we got y equal to 0? How we got y? How we the last
So,
part? How we
sir,
solve for t? Yes. Go
uh,
ahead.
we got that as 0 because you said hit the ball to
Sir, you
I'm listening.
substitute.
Hello?
Sir, you substitute
Oh yeah,
t.
go ahead.
Sir, you substitute t as 1.019 in the equation for that one. So the seconds will cancel out the other seconds to make it equals to meters. Then you do your normal subtraction. I get your answer.
Now, any question, those that ask the 3 questions one after the other, is it cleared? Can we move
But
forward?
sir, can I ask
Sir,
something?
yes.
Can
Please
I
go ahead.
one second? This y value, is it the time at which I sorry, is it the distance like the lowest distance or the maximum height gotten? Because
The
we
Now,
use the
total
time or the maximum height.
look at this question. They say find time, which is the third one. Find time when ball will hit the ground and the corresponding value. When the ball hits the ground, that's the maximum altitude, maximum height. And look at what we did. We solve for t at which altitude equals to 0 and evaluate corresponding velocity. When the maximum height is this relation, we have gotten time. We just substitute time. You know the time is at which velocity equals to 0, and that is when the ball hit the ground. So this is the time that we have such altitude they are talking about. We just substituted t for this height, altitude, and we got the height. Masood.
Okay, yes, sir. So this is the question is that these equations you are using to solve, like how was it derived? How was it gotten? That's what I just don't know.
Who can tell me how we got this? Look, this equation is not something you cram. Oh.
Yes.
We got it, and because it will not be exactly the same in every area. When we find the highest elevation reached by the ball and corresponding time. Find the highest elevation reached. And our elevation is the y, the t, equals to velocity. We use this one because we know velocity already, which is this. Which is this one. And when we substituted the y dt equals to v, then we cross multiply and we have the y equals v dt. And our v is 10 minus 9.8 t dt. So we just introduce integration sign and we integrate the y to have y of t minus y naught equals to this. And that is how exactly we got the equation. It's just a matter of integrating the y equals to v dt. And you integrate v dt. You know v, you substitute for v. We have this. What we got, the other one is that we find the t and we substitute for t in the relation to have the maximum height. Any other question before I move forward? We still have so I will because of my time, I have the assignment there for you that you will do. I have one other work example that is there. So I want to do the last part so that this one is just a recap. When you have uniform motion, for any particle in uniform rectilinear motion, the acceleration is 0 and the velocity is constant. That is exactly what they are telling you. And that is what the mathematical relation is saying. So somebody that said, can we use the equation of motion to solve all those things? You now see that all what we are playing with, they are just equation of motion, but in different forms. And that one, the choice of usage will be inferred by the way the question is being structured. Now, look at this one now. When we say the s dt equals to v equals to constant, that is the movement, the particle in a uniform rectilinear motion, acceleration is 0 and velocity is constant. So when this is constant, you can just cross multiply. The s equal to v dt, you introduce the integration and you get s minus s naught is equal to vt and x equal to x naught plus vt. When you look at this, this is an equation of motion. So whether you use wherever, you are still using the equation of motion. So also when you use Banjo Olajide, so also for particle in uniform acceleration, accelerated motion also, acceleration is constant. And that is what we do here. And by the time you introduce the v dt equals to a equal to constant, just find the v equals to a dt, the v equals to a dt, and you set the integration, you will still come back to v is equal to v naught plus at, which is also the uniform, which is also the equation of motion. So also the remaining. Now, this is the last part because I will stop by 8:30 or 8:25 for my yoga to continue. And that is relative motion. Relative motion is a situation, slide 21. Ozumba Precious, what is it?
Good morning, sir. Please, can you go back to slide 19?
Can I what?
Go back to slide 19. Thank you.
I will give you the slide immediately after the class. Is that okay? I will give you the slide immediately after the class.
Thank you, sir.
You're welcome. So, relative motion. When look at this diagram, the movement from 0 to A to B to X. Movement from 0 to A, that is, we target XA. From A to B is XB relative to A. And from 0 to B is XB. That is because this is the movement, which is the X. So when we now have, for particle moving along the same line, times will be recorded from the same starting instant, and displacement should be measured from same origin in the same direction. Now, when we now say x, that is relative position of B with respect to A, that is B over A. The meaning is xB minus xa. This for the sake of analysis, so that you'll be able to, for instance, we say a particle move from 0 to A at 3 seconds, and another movement of A to B is another 4 seconds. So what is the movement of 0 to B? That would be 3 plus 4. But if we say 0 to A is 3, and we say 0, we say A 0 to X, how will you know A to B, B to X? That's the reason why we use relativity. So when a particle move from one reference point and from that point to another one, so if you want to take the evaluation of time or whatever subject matter you want to evaluate, it will be from the same reference point. And that is what we are trying to say here, that relative position of B with respect to A means xB minus SA. Then from this one, you can just do change of subject or formula to have SB equal to SA plus SB over A. Then when we have relative velocity of B with respect to A, and when we have relative acceleration of B with respect to A, you see that it's still the same thing. Either it is acceleration or velocity or anything, it will be from of that B. That will be the first one. You now deduct with respect to the next position, you deduct it from it. So this is the simpler one that we are treating today. We can still go far beyond that. And I have a question for you, an example here for you. Now, when you see this look like the last question, but the subject matter, what exactly we want to take out there is not the same. A ball is thrown vertically from 12-meter level in elevator shaft with initial velocity of 18 meters per second. At same instance, open platform elevator passes 5-meter level, moving upward at 2 meters per second. Determine when and where a ball hits elevator. Number 2, which is B, determine relative velocity of ball and elevator at contact. These are the steps to take in order to solve the problem. We have to substitute the initial position and velocity and constant acceleration of ball into general equation of uniformly accelerated rectilinear motion. Because when you throw ball vertically, so we are talking about a uniform accelerated rectilinear motion. Then number 2, you substitute initial position and constant velocity of elevator into equation of that uniform rectilinear motion. You write out equation of relative position of ball with respect to elevator and solve for 0 relative position, that is impact. And the last one, you substitute impact time into equation for position of elevator and relative velocity of ball with respect to elevator. When you are reading this, it will be like you are reading history. But when you start doing it one after the other, you now get it clearer. If you want to do it, it is solved here. If you want to do it, take your question by side you and follow the step one after the other. In order to substitute the initial position of velocity and constant acceleration into general equation of uniform motion or uniform accelerated rectilinear motion, we have velocity at point B is equal to V naught, which is normal u plus at. What is our V naught? Initial velocity 18 meter per second. What is our acceleration? A, which is minus 9.81 because of direction. What is time? We don't know it. We put this one. We find for the elevation also. YB is equal to Y naught plus Y V naught T plus half AT square, which is normal equation of motion. We substitute for the highest altitude, which is 12, plus 18, which is our V, we don't know T, minus this. Then for the other one, we substitute, I'm coming, Quadri Lawal. We substitute for initial position and constant velocity of elevator into the same equation. Our velocity also A at E, then we have 2. At the altitude, we have the same equation of motion, rectilinear motion. For the altitude, YE at point E, this is the altitude at E, is equal to Y naught, which is initial altitude, plus VE, velocity at this initial altitude, which is the 2 meter, and T is equal to 0. Then you have this. The last one, you write equation of relativity. Y of B relative to E. This is Y of B, this is E. Then you substitute, you solve for T. And the other one also, V of B relative to E, you substitute. That is exactly what we did. There are two steps we took there. Number one, we wrote out the uniform equation of motion for those with acceleration, for those with the altitude. Number two, when you sketch the diagram, you write for relativity, relative positions of each one in question, and you start substituting. That's all what we did. Yeah. Questions? The first person that I said I will call, who is that person?
Sir, it's me, sir.
Oh yeah, go ahead.
Sir, please, slide 23 very well, please. I didn't get it.
You didn't get which one you did get?
Slide 23.
Slide 23.
Yes.
Slide 23.
Yes, 33, the initial position and velocity and constant acceleration of the ball, general equation for uniformly accelerated rectilinear motion. I didn't understand that part.
This is, we want to find final velocity. And final velocity at point B. This is when you draw the diagram. This is the highest altitude at B. We want to, this is the initial altitude, Y naught, which is 12. Final Y, we don't know. Then our A, because it's coming down, minus 9.81. And our V naught, we have 18. So the first thing we want to find the final velocity, we see final velocity is equal to V naught plus 80. You know that one to get the final velocity. That is how we got this one. Now we want to find the altitude, the height. This is the final height. We know the initial height. We use Y final is equal to Y initial plus UT plus half AT square. We know A, we know V naught, we know Y naught, and we substitute. We got this relation. From these two, we don't know T. But for the second one, we want to find final velocity at the point of E, and that is 2 meters per second. It has been given. It is that. We want to find the final altitude at point E. We are given the initial, and that is this one. Because, do you know, we are still using this equation. But why is V naught T is omitted here? Because at this point E, our T is equal to 0. So when T is equal to 0, this one is omitted, is 0 already. So we have Y naught plus VET. Our Y naught is 5 meters. Our V is 2. We don't know T again. So we have 5 plus 2T for our highest altitude. Is that one cleared? Rahman Jubril.
Sir, like this, can we solve this one as we solved it the last time? Or is this another method of solving it?
If you use another, you see, you can use so many methods to get it. But the subject matter, the reason why we are giving you this is because we want you to understand what is called relative motion.
Okay, sir.
I'm not disagreeing that you can use another method to get it and you'll get the answer. But you may not go in the route of relative motion. Okay, for winner.
Sir, please, I want to know the way you are switching those your formulas. Like in that one when you said YB is equals to Y naught plus V naught T plus half AT square. And the other one when you say YE is equals to Y naught plus VET. Now I don't really get how you are switching your formulas.
We use the same, it is the same formula. But here, YE is equal to Y naught plus V naught T plus VET. But when you look at this diagram, T at this initial point, T is equal to 0. And when we put V naught multiplied by 0, our V naught has been because we have our final V, which is 2 meters. So here we're supposed to have Y naught, which is 5, plus V naught T plus VET. V naught T at that initial is 0. Is 0 times V naught. That is 0. That is the reason why we have VET. Is that one clear now?
Yes, sir.
Any other questions? So when you have all these equations, then we can now substitute for the relative, the height of B relative to E. B, what we have for final y of B that we have there, that we solve here, this one for B. This is what we have there. For y of E, this is what we have here. And you substitute it. Y from the position of B relative to E, YB minus YE, as we did here. X from relative position of B with respect to A will be XB minus XA. So also when we have here YB relative position of B with respect to E will be YB minus YE. And our YE is this. YB is E, YE is this. So we now have YB, which is 12 plus 18T minus this, minus ye. Then we stop when you open the bracket, you find the quadratic equation and you get t equal to minus 0.39 and t is equal to 3.6. And you know, since time we don't have negative here, we make use of 3.6. So also y of e, when you put it here from here, you know y of e. You know y of e, then we want to find velocity from the position of B relative to E. And we find velocity of B minus velocity at E. Then we get this value. Adejumobi.
So,
I'm listening to you. Raise up hand. That's the reason why I call you.
for the second part of the question for the elevator, why did we not use the formula of YO plus VOT plus half AT squared since the elevator is also moving upward?
Yeah. Where? This one.
Yes, why did we not use the same formula for solving the second YE?
We use the same formula. Y naught plus V naught T plus half AT square.
But the half AT square was not shown in the second one. That's what I'm trying to say.
I will look into that and get back to you.
Okay, sir.
Because my time is up.
Okay, sir.
So how do you get t to minus 0.39?
When you open the bracket, you will get quadratic equation because of 4,905 t square has turned to quadratic equation. And when you solve for quadratic equation, you have 2t. And that is how you have this 2t.
That is, why do we take why the position of the relative to e to the 0?
Please speak louder. Your voice is not audible here.
So why do we take the y relative of b relative to e to the 0? Why do we take it as 0?
Please, so who had him? Can that person speak out so that I will hear him out?
So why do we the position of b relative to e to the 0 when we want to solve the quadratic equation?
When you have quadratic equation and you want to find you want to solve for t, you just equate it to 0 to 5 to get your t.
Okay, sir.
I am giving it.
Sir.
Yes.
Please, where are we going to get the slide from?
Don't worry, it will be given to you. Don't worry, it will be given to you. So, I want to ask my yoga, Dr. Mrs. Folonso, to step in and take you apart. Enjoy the class.
Thank you, sir.
Thank you, sir.
Thanks, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thanks, sir.
Thank you, sir.
Thank you, sir.
We really appreciate.
Thank you, sir.
Thank you, sir.
Thank you, sir.
We really appreciate.
Thank you, sir.
Thanks, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Good morning, everybody.
Good morning, ma.
Thank you.
Good
Thank
morning,
you.
ma.
God bless
Good
you.
morning, ma.
So, can you please mute your mic? Please mute your mic.
Thank you, sir.
Good morning once again. And we really want.
Good morning. Ma, I think your mic is in.
Yes, I've unmuted myself. Thank you. So we want to thank God for the opportunity that He has given to us to be able to meet this morning. And you could say that we really want us to cover up because of the so many activities you guys had in December. We couldn't really meet because of your orientation and everything. So that is why we are starting as early as 7 a.m. today, so that we'll be able to have enough time to discuss. By the grace of God, next week, which is 13th, we'll be having physical class next week. Then I think upper week is convocation week, that's 20th. For that convocation week, we'll be having online class as early as 7, as we did today. We'll be having online class the week of convocation. Please have it in mind. But next week, we'll be having physical class so that we'll be able to, from upper week, on the 27th, we'll be having physical classes, because mathematics is better taught when we see one another one-on-one. And as you know, whether you like it or not, the time is ticking and the time for exam is drawing closer. So please, some of us, we have we always like to ask questions, even the questions that are not relevant. This particular course is extension of your physics in your undergrad, your O levels. So if you calm down and listen to the lecturer, you'll be able to get all the information that is being passed. So I just want you to calm down. Even though you know it, just calm down, okay? And listen to what the lecturer has to say. Then you can ask some questions. Last time, the first time we met, I shared the slide, but subsequently, I might refer you to some other materials. Without necessarily sending you the slide that I use in class. But you will definitely have something to work with. And I've asked them at the site here to migrate to LMS, that's our learning management system. I will inform your class reps and they will pass it across to you. Once in a while, maybe every week or every 2 weeks, we'll be having some tests, some quizzes. Okay, we'll let you know. We'll be having some quizzes so that we'll be serious with whatever we are doing. So I want you to be serious, because the primary reason why you are here is for your academic. So leave every other distraction alone and focus on your academic. Like the 100 level is the foundation level. If you build your foundation right now, you'll be happy for it. And in Unilife, there are so many distractions. So I just want to implore us that we should know why we are here and we should focus on it. Thank you very much. So let me share my slide. I want somebody to help me quickly recap. I'm going to share my slide. I want someone who will help me to recap on what we did last time before we go to what we have today. If you want to answer my question, I would really appreciate it if you raise up your hand. so that everybody will not be talking at the same time. So who wants to help me out? Who wants to recap what we did last time? Quickly. If you want to answer my question, you can raise up your hand quickly. Nobody? Wisdom, is Wisdom there? Wisdom Boyelade, are you there? Wisdom Boyelade, is he there? Wisdom, I know you are there, unless if it is your device that is connected. Can you try to recap what we did? I don't think he's there. Okay. Okay, you are there. Can you help us to recap what we did the last time, in the last class?
We did vectors, unit vectors, addition of vectors. Yeah, basically just unit vector and addition of vectors, basically.
Okay. So for those of us, thank you very much. For those of us that couldn't join last time, I know I shared this particular slide. So we did vectors, introduction to vector, how we can represent vector, and I told you that you start your angle from the positive x-axis, then anti-clockwise. Please note that. And we talked about unit vector, we talked about the magnitude of vector. From what we have on the screen, who can quickly remind us, how do we calculate the magnitude of vectors quickly? Do we have Fashanu on the call? Is Fashanu on the call? Okay. Tosin, can you quickly tell us about that? How can we calculate the magnitude of vectors quickly from what we have on the screen?
Okay, we can calculate the magnitude of vectors by finding the sum of the squares of each of the vectors and find the square root of all of them.
Thank you very much. Thank you. So we can also find angles between two vectors like we have seen here. If you have vector A and vector B, we can find angle between two vectors. We'll do more of that today. Using dot product, we'll do more. And we have some definition of vectors. And we can find, when we have 2 points A and B, we were introduced to how to find the midpoint of those 2 points. Then we can resolve vectors into various directions. The I direction is the direction along x-axis. The J direction is the direction along y-axis. And the K direction is the direction along z-axis. And we look at some examples. And we were given some assignments, and we also look at operations of vector, additions. So we are going to look more on that today. So let's go to today's class. Let me share my screen.
Sorry, excuse me, ma'am.
Okay.
Good morning, ma'am.
Good morning.
Yes, Lapis, I have a question from the assignment from the previous class.
Okay.
Yes, on question 2. I don't know, I can't see the slides here, but I think it asks us to use something about representation of vectors. So I don't know if that can be recapped because I do not really understand it.
Let me quickly look at that. The assignment that was given, right?
Yes, ma'am.
Represent the following vectors on the rectangular axis. Yes, like when you can represent vectors in various ways, either with equation as you have, or you can represent them using the Cartesian block. Remember that the top right part is where x and y are positive. You understand? Then the top left side is where y is positive and x is negative. Then the bottom left is where both x and y are negative. And the bottom right is where x is positive and y is negative. So we can draw vector along this. When you have 5i minus 4j, that means you know, I say you are using number line. You locate 5 where we have 5 along the x-axis, and when we have minus 4 along the y-axis. Is that okay? And that is how you're expected to draw others. Is that okay?
Yes, ma'am. I think I understand that.
So thank you
Thank
very
you.
much. So let's go to today's class. I hope you can see my slide. So we want to continue with vector.
Yes, ma'am.
Thank you very much.
Ma,
Yes, please.
please, the last note. I didn't like the last one. Please, can you send it?
The last what?
Can you send it like?
I sent the
Yes,
slide the first time, but I'm not sending this particular one. I just said it. But I will send you the material that you use. Okay? I will send you the material that you read. I'm not sending this particular slide. Okay, please, let's get to work. Let's get to work. Thank you. Please mute your mic. So we want to look at continuation of vector addition, vector subtraction, and vector multiplication. So at the end of the class, you should be able to handle different methods of vector addition, the rectangular component of a force, do vector subtraction, and multiplication of vectors. So I know in your lower levels, in your O levels, you've done something on triangle law of addition of vector. Can you still remember?
Yes, ma'am.
God bless you. So the law says that if two sides of a triangle represent two vectors, both in magnitude and direction, acting simultaneously on a body in the same order, then the third side of the triangle represents the resultant vector. Like as we see, the side AB and side BC, there are two different sides of a vector. So that side AC will represent the resultant. That is, by the time you add AB and BC, you'll be able to get AC, which is the resultant side of the vector. So, and according to the triangle law of addition of vectors, we have a squared plus, I know you can still remember this, so that when you are considering the side A, the angle beside it is the angle opposite it is the angle that you are going to put in the course. You know, we are going to look at one or two examples as time goes by. So we can also, from this a square is equal to b square, you use that to find the side. And from here, we can also find the angle, the cos x. Once you get the cos x, you can find x using arc cos. Then we can also find the, use the sine rule to find either the side or the angle. And this is the sine rule. A all over the angle, the sine of the angle opposite it. Side B all over the sine of the angle opposite it. And sine C, C all over the sine of the angle opposite it. It's either you do it that way or you say sine x all over A is equal to sine y all over B. The main thing is, once you are considering the angle of the sides at the top, you must be consistent. Don't say A is equal to sine x, then not is equal to sine y is equal over B. You understand? You have to be consistent. Either you are putting the side up over the angle, or the angle of over the sine. We'll look at some examples as time goes by. So let's quickly look at this example. Find the length of x and the other two angles in the following figure. Yes, Usman, you are raising up your hand. Can we hear you?
Isma, I do not understand what you just said.
Which one don't you understand?
The last slide just.
The last side is the same thing with your triangle law that we did. You understand? That, you remember how to get this. A squared is equal to
Yes,
this.
yes, ma, yes, ma.
Now, you can get the angle by saying cos x, you make cos x the subject of the formula.
Yes, ma.
You can remember. And the sine rule. The sine rule is when you say this is side A,
Yes,
all over the sine of the angle opposite that side. You understand? Is equals to B all over the sine of the angle opposite side B. Is equals to C all over the sine of the angle opposite side C. Can you see? And that is the sine rule.
Yes, ma'am.
And I said that either you say the side all over the angle, or you say the angle all over the side, depending on whichever one you want to use. You still get the same answer. Is that okay?
Yes, ma'am. Thank you, ma'am.
Thank you very much. So I want us to try this example. I want us to, of course, I know I've done it, but I want you to try it. I want you to find the angle x. The side x. The side x is equivalent to side B. You understand? Side x is equivalent to side B. So I want you to find B, side B from this question. Can you quickly do that? And tell me your answer. Please, I will appreciate it if you can raise up your hand if you want to answer the question. Wealth, Evans.
Ma, 37.65.
Oh, study is no number.
Ma, put on your mic. Oh.
Ma, you are muted.
Okay, thank you.
The answer is 5.
God bless you. So we have
Your mic.
Your mic.
Okay, so please try as much as possible not to mute your mic. Not to unmute. Only if you want to talk, you can raise up your hand, then I'll call you. This is a learned class. You should be able to behave, as those people in our institution, different from the people in the secondary school. So if you want to talk, just raise up your hand. I will see you here and I will call you so that we don't make the class noisy. Okay? So I said that if you want to get x, so it will be x squared is equal to 22 squared plus 28 squared, then minus 22 times 28, then cos 97. Now, if you want, we are also asked to find the two remaining angle. Can somebody volunteer? If you want to do this, you will use sine rule. We have the three sides now, and we have one angle. So we will use sine rule to find the two remaining angle. So I need a volunteer who will tell us how to go about it. Okay, Ayotunde.
Oluwajeyo.
Okay, Ayotunde, you have the
Okay.
floor. Unmute yourself and talk to us. Thank you.
Good morning, ma.
Good morning.
First of all, since we already have the x as 37.7, if we want to find the side, okay, the angle A, the angle at A, we are going to apply sine rule. That will be sine A over 22 equals to sine 97 over 37.7. Then of course multiply and solve.
And what did you get?
But I've not solved them, please solve it, ma.
Okay, thank you very much. So that's what we are going to do. And if you solve it, you have 35.4. Okay, you can confirm that. So once you get that, remember that the total angle in a triangle is what? What is the total angle in a triangle? Who can remind us?
180.
180.
God bless you. So you now we already have 2.
180.
Thank you. We already have angle at A and angle at B. So we can get angle at C by saying 180 minus 97 plus 35.4. By the time we do that, we get 47.6. Is that clear?
Yes, ma.
God bless you. So
Yes,
now,
ma'am.
the second thing we are looking at is the parallelogram law of addition of vector. The law states that if two co-initial vectors acting simultaneously are represented by the two adjacent sides of a parallelogram, then the diagonal of the parallelogram represents the sum of the two vectors, that is, the resultant vector starting from the same initial point. If these two vectors A and vector B are the co-initial vector and acting simultaneously, as we can see it, but as the adjacent side of a parallelogram, we can also draw a resultant vector. Of course, if you have A this way, we can complete the parallelogram as you see with the dotted line, such that you now put a diagonal vector from the initial point that A and B are starting from to the end point, which will now be our A plus B. So that is the resultant vector of the two vectors. And we can calculate that. We can calculate that as we are going to do shortly. So we have this question. The two forces act on a boat. Like we know that vector are all around us. We apply vector every day of our lives, day in, day out. How many of us have tried to unlock a nut before? You have tried to unscrew a nut before. I know many of us would have tried to do that, either doing some mini engineering work at home or trying to change our daddy's flat tire. You understand? So all those things, there are some engineering principle behind it. We just do it normally and we are good, but there are some engineering principle behind it. So in this case, let's look at this. We have two forces, and the two forces are being acted on a boat at point A. So we want to determine, if one force P is acting at angle 20 and another force Q is acting at angle 45 from, remember, I told us last time that by the time you are finding your angle or you want to find the angle of your vector, you start from the initial positive x-axis and you move anticlockwise. So the angle of Q is 45, but between P and Q, you have 25, okay? So we want to determine the resultant force. You can do this in different ways. Either you use graphical solution. Graphical solution means you are going to use graph. You are going to draw to scale. I want you to try this later, okay, after the lecture. You will draw to scale. I know you can still remember how to do that. You did a lot of graphing when you were in your O levels. So you need that skill now. You draw to scale and you'll be able to find the resultant. You can also do that using the trig method. Okay, so let's look at, if you use graphical method, you will get that answer. But let's try to see how to do that using the trig method. So you apply the triangle rule, that is the law of cosine. So now I will draw the two vector, then you will find the resultant. I know we already have it, but you still find it for me. Remember, we said that angle A, I mean, force P has 20 degrees to the x-axis. As you can see, you draw that first, force P. Then you now draw force Q, which is 45 degrees from the x-axis. Like, by the time you get to this point, you can draw your horizontal line. So this is 20 and this is 25. So everything will be 45 degrees. Can you understand that?
Yes, ma'am.
Thank you very much. Thank you. So by the time you do that, you now find your resultant starting from the initial point to the end of the second angle. So you can now find your resultant. So using the sine rule, I want you to quickly solve it and tell me what the angle will be. Can you quickly do that? I'm not going to answer anybody without a name. Dr. Rahim just told us that we should use our name to save whatever. So any Zaomi, whatever, I don't know you. I can only attend to you when you have your name written. Yes, Ramon, can I hear you?
Please, can you show the question again?
Okay. So we want to find the resultant force of these two forces. You can use different methods. You can use the parallelogram method. You can use the trig method. You can use the graphical method where you draw to scale. Yes, Bright. You can ask your question.
But you don't know the graph angle 155.
What?
I want to know how you got angle 155.
Okay. Like, if you look at it, this is 20, right? So this is angle 20, isn't it? So this is also 20, Abi. Then, if you look at this, this is, we have angle 20 plus 90, then plus 45. Can we quickly add that together? Okay. We have, let me come over, let me, okay. You have this. Okay. So we have, this is angle 90 here. Then this one here is angle 45. Remember, I told us you have 20 plus 25. Okay. So that means the remaining angle here will be what? 45. Then this other angle, this is 20. Remember your alternating angle, your opposite angle. So this will be 20. So this angle 20 here plus 90 degrees here plus 45 degrees here will give you 155. Is that clear?
Yes, sir. Thank you.
Okay. So can we confirm the answer, please, of what we have? What is the resultant vector using the law of cosine? And when you find the resultant vector, you have to find the magnitude as well as the direction. Yes, Idris, you have the floor.
Good morning, ma'am. Sorry,
Good
please,
morning.
how to get the 155-degree?
Is it that you guys you don't listen when somebody else is asking a question? Somebody just asked now and I try to explain. So can someone help me to explain? How did we get 155 degrees?
180 minus 25.
Okay. Japrike.
180 minus 20.
And we did 180 minus 25.
180 minus 25. Okay. But I use another, you are right, but I use another method that will help you to understand it. I mean, that will help you to see. Okay, I have two people raising their hand.
See that is a straight line. Don't just subtract 25 degrees from me. They give us 155.
Okay, so I hope you can understand that for the person that asked the question.
What did they say you are too fast?
Okay, I was told that I'm too fast. I will try to be a bit slower. Okay, so who else is raising up his or her hand?
Okay, Faye.
Okay, Faye, can we hear you?
Ma, if you look at that angle 25 degree, if you look at that angle ACB, can't we say that this 25 degree here is alternate to that angle ACB, so that we can make that angle C, this part of angle C, to be equal to 25 degree.
Well, I can see where you are coming from, but I wouldn't want to agree that angle AC is 25. Do you know why? You know, even though the where's my cursor? You know, even though this angle is going this way, this other one that has 25 is different. This is coming here and the other one is going like here, you understand? So they are not the same thing. You understand? They are not. So it's either we try to bring it out from, like what I said, let me explain that again. We have this. Let me try to draw a parallel x-axis here. Let me do it step by step. Can you see my parallel x-axis?
Yes, ma'am.
Okay. And I said, remember, when I first asked the question, I said that even though Q has 25 degrees we have 25 degrees between P and Q, okay? And I said that if you want to draw your vector, you start from the positive x-axis and you move anti-clockwise. Is that okay? Now, this angle, you agree with me that it's the same thing for the P that was drawn. It's the same thing with that one. Do you agree? Because it still goes, that line still goes till forever. Do you agree with that?
Yes, ma'am.
Now, and we were told that the angle between P and Q is 25, which is this one. Do you agree?
Yes, ma'am.
Yes, ma'am.
Now, if I'm to draw the angle of Q from the x-axis, what angle will it be?
45 degree.
45 degrees. Thank you. Now, let me draw my vertical line, okay? So that if this is 45 degrees, what angle will be here? What angle will be here? If this one is 45,
45, ma'am.
so this one will also be 45.
45.
Thank you. And remember, we have three angles. We have 1, we have 2, and we have 3 that make up the angle at B. Do you understand that? So that means we are
Yes,
going
ma'am.
to add up the three angles. That is 20, which is opposite angles or alternate angles. 20 plus 90, then plus 45. Can you see that?
Yes, ma'am.
Yes,
So
ma'am.
the addition of the three angles will give us 155. Is that okay?
Yes, ma'am.
Okay. So let's continue. So have you now find the resultant now? Has anybody tried to confirm if what we have here
Yes,
is
ma, it's
correct?
correct.
Yes, ma'am. I've
Thank
Yes,
you
ma,
confirmed it,
it's
ma'am.
very
correct.
much. Thank
I've
you.
confirmed it.
Oh, God
Confirmed
bless
it,
you.
ma'am.
Now, we need to find the angle at A. Can you find the angle at A for me using sine rule? What did you get? Can you find the angle at A for me using sine rule?
15.04, ma.
15 points.
04.
15.04. So thank you very much. So if A is
Ma,
15.04, yes, please.
15.04 be added to that 20 because A is the
Exactly.
root of
Exactly.
15.04.
So if you want to find the angle for the resultant force, remember it is starting from the positive x-axis. It's starting from this x-axis and it's going in that direction, remember. So it will now be 15.04 plus 20. You understand? That 20 degrees, which is 35.04. Do you
Okay,
understand that?
yes, ma.
Is
Please,
that the
class.
direction for the resultant?
What?
Is that 35.04 the direction of the resultant?
Yes, that is the angle. You can see it. See the direction here. See the resultant here. See the resultant here. Even it is. So we are looking at the angle this resultant make with x axis. Okay, which is 15.04 plus this 20 degrees here. Can you see it? Which is equals to 35.04. And that is the direction of the resultant angle. Is that clear?
Yes, ma.
Okay.
Yes.
Yes, ma.
Yes, ma'am.
Thank you very much. So let's quickly look at rectangular components of a force. Remember, when you have Moshood, why are you still raising up your hand?
Yes, ma. Sorry, ma. The other slide, you said the direction of the resultant. I just want to ask that direction of the resultant does that mean that the direction of the resultant is going to be the angle that the resultant makes with the horizontal line.
Exactly. That's what I just explained too. Let me go back. That's what I just explained. You understand? We'll find A, which is the angle within the triangle. But that is not the angle of the resultant. The angle of the resultant is the angle the resultant make with the x-axis. You understand? With the horizontal line, as you rightly said. So that is why we are adding that this 20 degrees, which is the angle of the P. that we first drew. Is that okay?
Yes, ma'am.
So, rectangular component of vector of a force, like I said earlier, every vector have magnitude and direction. And depending on if it is a two-dimensional vector, a three-dimensional vector, we have them either in x along the x-axis, along the y-axis, or along the z-axis. And I told us that the unit vector along the x-axis is the I. The unit vector along the y-axis is the j, and the unit vector along the z-axis is the k. So we can also do addition of vector using the rectangular component. Okay, we can find the addition of vector using the rectangular component. We can also find them using the resultant method like we did. We can use different methods to find them. Let's look at this example. 4 forces are acting on the boat. Before we have 2 forces, but now we have 4 forces. And we want to find the resultant of these 4 forces. To make it easy for us, what we need to do is to find, like each force, like force F1, for example, you can resolve force F1 into x-axis and y-axis. Okay, how do I mean? This force F1, you can resolve it into y-axis as well as x-axis by completing, as you have it there, you just complete it like this, such that this one is the x-axis, which is fx, the x equivalent of that force 1, F1x. And this particular one opposite the angle is the Fy, which is the F1y. Okay? So we can find the x component as well as the y component of each of the forces and then sum them together. So we are going to do that now so that you can see what I'm trying to say. And if you want to do that, I will advise you that you draw a table. If you are given a question similar to this, draw a table so that you can see what you are doing. Then you draw F1. So in this case, this is F1 now. What is the magnitude of F1? 150 Newton. Okay? 150 Newton. That is the magnitude of F1. Now, what is the x component of F1? This is the x component. Let me draw my... So this is Fx, and this is Fy. Can you see that? So who can tell me what will be our Fx? If you want to find Fx, how can we find this Fx? Yes, Chibuke. Can you tell me how to find the Fx? Good morning.
We use some trigonometry something to find fs on that day. That's 150 times it by cos 30.
Thank you very much. Thank you, Chibuke. In your O levels, you did something called SOHCAHTOA. In this case, this side is our x, which is adjacent to the angle. Okay? So for you to find fx, you have your car, that is cos 30 is equals to adjacent side, which is our fx, all over the hypotenuse, which is 150. So if you make fx the subject of the formula, you have 150 cos 30, as Chibuke rightly said. So if you multiply 150 times cos 30, what will you get? Who can tell me? What will you get?
129.904.
Okay, let me quickly clean this so that it not distract us.
$75.03.
Now, I think you are right, my dear, but I think I would like the point for now, you understand, so that we can compare it with what we have. Is that okay? So, you can see that the x component of my fx is 129.9, as you rightly said. Then the y component will be what? Who can tell me the formula to get the y component quickly?
Map is not this table.
Sin
Then
F sin theta.
you use sin theta.
Is F
Yes,
sin theta.
150
F sin theta.
sin
150 times
30.
130.
Thank you very much.
75.
And what do you get?
75,
75.
man.
75. Beautiful. So that is that for F1. Let's look at F2. This is F2. What is the magnitude of F2? 80. Now, can we resolve this F2 into the X and Y axis? I want somebody to raise up his or her hand to tell me, okay, Folakumi, you have the floor. Can you resolve F2 into X and Y axis? Tell us how to go about that.
So since we have gotten the first one, which is 150 Newton, so to get the F2, so for x-axis, it will be from the first point of the x-axis, it is 30. So when coming to the other side of F2, it will be 90 plus 20. So for the x-axis, it will be 80 cos 1110, and for the y-axis, it will be 80 sin 1110.
And what did you get? Can you try to find it? Can you try to find it and tell me the answer? Isaac, I can see your end, but hold on. What did you get? Folakumi. Yes, Isaac, can we hear you? Isaac, look, because I can
Okay,
see
ma.
two Isaacs.
Okay, ma. So for the F2, if we want to resolve it, we can use two methods. The first one, the other guy has said. The other method we can use is that we can find the angle that F2 make with the x-axis. So we are given the angle that F2 make with the y-axis. So to get that of what it make with x-axis, we just have to say 90 minus 20, which is 70. So F2 will just be, if we want to resolve it to S and Y component, for Fx, it will just be like F2 cos an 80 degree, which is 80 cos 80 degree.
70.
For the Fy component, it will be 80 sin 80 degree.
70 degrees, you mean? Very true and
I mean,
very
no,
good.
it's 70 degree, 70 degree.
Yes, so I want you
90
to,
minus 20.
can you do that and tell me the answer? Thank you very much, Isaac. And that is what I want to encourage us, that when we see a question like this, it's better you resolve it into, you find the angle along x-axis. You understand? So that you always use cos for the x component and sine for the y component. Because if you are using the angle with respect to y-axis, you can see that it will change. If you are using angle with respect to y-axis, then this by the time you close this up now, the fx will now be sine fx will be sine, not cos. So if you are not careful, if you are using fx cos in one area and using sine in another area, you are going to mix it up yourself. But if you are just gone ahead to find it this way, so that your angle will be with respect to the x-axis this way, then this will be 70 degrees, and it will be easy for you to find, it will not, your fx will still be the one adjacent, which is cos, and your fy will be the one opposite, which is sine. Do we have any question? I saw some people raising up their hand.
Solve each force into rectangular component.
What? Who is talking?
Jimo be like talk.
Jimo, do you have anything to say?
Excellence.
Excellent.
ma.
Yes,
Ma, the
please.
answer is 75.2.
Oh, okay, you want to give me the answer? Okay, let's go there. Did you get minus 27.4 and 75.2?
For the
Yeah.
fx, I got 75.2. But for the f, I have not solved it yet.
Okay, can you quickly solve that? And you can see that for F2 now, the x component is negative. Why? Because F2 is, the x component of X2 is along the negative x-axis. So you need to put that into consideration. If not, you are going to get a wrong answer. You understand? You need to note the positive x-axis, the negative x-axis, the positive y-axis, as well as the negative y-axis. Once you know that, put the respective sign in front of your value and you'll be good to go. So have you gotten that? Who want to tell me, did you get
Yes,
x to
yes.
be
The
minus
fy, I got
27.4
minus 27.4.
and y to be 75.2?
75.72.
God bless you. God bless you all. Remember, I said that yes, I have two people raising up their hands. Chibuike, what do you have to say?
Okay, ma, just have a question. When we do 80 times cos 70, we are going to get 27. So are we going to put the minus there by our own hand because the thing is on the negative x-axis?
Yes, sir. You will use your own hand to put it there because
Okay,
it is
thank you.
along negative x-axis. You understand?
Okay, ma,
You
thank you
need
very
to
much.
put everything into consideration.
Okay, thank you very much.
You're welcome. So, then who can solve? Adela, do you have anything to say?
Yes, ma, I have a question, ma.
Oh, God bless you. I hope you are good.
Yes, ma. So sorry to take you back, but when you were explaining how to resolve the forces both to the x and y components, my network was acting out, so I didn't quite hear what you explained on it, ma.
Okay, let me quickly go back. I said that when you have forces like this, that I will advise you to always find the angle along x-axis. You understand? Either positive x-axis or negative x-axis. In the case of F2 now, you were given the angle of F2 along the y-axis, which is 20 degrees. But I said, like one of you also showed us, that it is better you find the angle that this F2 make with x-axis. So that means you close it up this way. Can you see that? So when you close
Yes.
it up that way, remember this is my horizontal. So this will be my angle, which is 70. So my x component can still be cos adjacent, you understand? And my y component will still be sine. opposite. So that means if I want to find the x component of F2, it will be 80 cos 70 degrees. But I will now put the negative because it is along the negative x-axis. And my y component will be 80 sine 70 degrees. I don't need to put any negative because my y component is still along the positive y-axis. Is that okay?
Yes, ma. Thank you, ma.
Okay, thank you very much. So, who can tell me resolve the F3 into x and y components? Who can do that for us quickly?
My F3y is minus
Sorry, ma, what did you
110.
say?
Oh, wait, someone is talking already. Okay, who is that? Who is talking to us?
Mom, the woman.
Right.
Michael, right?
Yes, ma'am.
Okay, Michael, you can go ahead.
Okay, ma'am. F3 is since it already acts straight downwards, it's not going to have an x component. So F3y is minus 110 since it is the negative since it's negative y, and then the F3x is 0, ma'am.
Thank you very much. You can see F3 does not have a x component because it's directly vertically along the y-axis. And F3y will be 110, but minus 110 because it is along the negative y-axis. Did you get that? So I want somebody to help us with the last one, F4. Okay. Jack.
I'm not so I did not understand the F3 X.
Okay, don't understand. Okay, like look at it. The
What do you
the
call it, sir?
F3X. Can somebody,
Between
another person
I
help
don't
me to
know.
explain how the F3X is equals to 0? Can somebody help me with that?
Okay, ma. Can I start?
Okay, go ahead.
Okay, so the F3x is equal to 0 because if you do 110 cos 90, because the force is making an angle of 90 with the horizontal, and cos 90 is 0, which will make the horizontal force to be 0.
God bless you.
Okay.
And 110 sine 90 is what? Sine 90 is 1. So that is why it is still 110. Can you get that? And that is why I said that we should always do our angle in such a way that you can have your cos associated with x-axis and your y associated with y-axis. You understand? Then somebody should help me with F4 quickly. Our time is ticking.
So now, the vertical component of F4 is 46.98, that is 80 times 70, which will give us 46.98, while the horizontal component is minus 17.10.
Can you tell us how you got that? You understand the equation?
Okay, the horizontal component, that is 80 plus
Is
70.
it 80 or 100? F4.
Okay, F4, okay, sorry now. The F4 is the horizontal component of F4, that is 100 cos 15, which gives us 96.59 Newton, while the horizontal component is 100 times 15, which will give us minus 25.9.
God bless you. You can see. So you will now add everything together. All the x components, you add it together, and all the y components, you add it together. So can you do that to tell me the answer quickly?
It's not the apple.
Okay. How many of us got this?
Me. Yes,
Yeah.
it's correct.
Okay, thank you very much. Now that is the resultant, but the resultant component still has the x component as well as the y component. So we need just one angle, as in one force. We need to combine it to get one force. And to do that, we have this. I say you want to find the magnitude like we normally do. So you find rx squared plus ry squared, then the square root. So by the time you do that, you find the resultant component to be 199.6 Newton. Then to find the angle, remember, just like we did in the previous one, the resultant will always have an angle, okay, because it's a vector. So to find the angle, you have TOA. TOA means opposite all over adjacent. And what is the opposite? The y-axis, which is 14.3 all over adjacent the x-axis, which is 199.1. 14.3 divided by 199.1, whatever you get, you find the arctan of it so that we get 4.1 degrees. Did you get that? How many of us get that?
Yes, ma'am.
Yes,
Well,
ma'am. Yes, ma'am. Yes, ma'am. Got it.
thank
Yes,
you.
ma'am.
Yes,
So
ma'am, we've got it.
let's
Yes,
move ahead.
ma'am.
Yes, please. Who is trying to call me?
Jimmy Abdullah, what do you want?
Dima Abdullah.
Yes, ma. Yes, ma. Ma, please, can you return it to the previous slide? I want to ask question. The first one.
What?
The previous one, ma.
The previous one?
Yes, ma.
Not this one.
Yes, ma. Yeah. For that first one, for that F4 that is inclined at 15 degree.
Yes.
You said that the horizontal force of it is 100 cos 15 degree. Why the vertical is 100 sine 15 degree.
Yes.
But how did the minus come in? I don't understand how the minus come in.
Can somebody help me out, please?
Now, the negative sign came in because of the y component in that part is negative, is downwards, negative part of the graph.
Did you get that?
On the Cartesian plane, that place is minus. That
Okay.
place, that downside is
Okay, because the
If you resolve it, it will look this way. So the F component is along the negative y-axis.
this axis. Okay, yes, ma. Thank you, ma.
You're welcome. We still have a lot of things to do, but let's see where we can stop today. So we can also subtract vectors. We are just with different ways that we can add vectors. We can also subtract vectors, okay? By, I told us last time that we can add vector this way by adding all the I components or all the components along the x-axis, all the components along the y-axis, and all the components along the z-axis. We can also do the subtraction the same way. That is a1 minus b1 I plus a2 minus b2j, and so on and so forth. So let's quickly do this. Can somebody quickly help me to find this? A is equals to 4i minus 2j plus 5k. And B is equals to 5i minus 2j plus 3k. Find A minus B. Who wants to quickly explain how to do that for us? Quickly.
Now, okay, so for the A,
What you are
the
going
A is already given to us to be 4I minus 2J plus 2 5K. What we'll do is we'll
I
subtract
told you to
we
go and do that thing. What is your problem?
so we'll
Hello,
subtract
if you
them
are not
according to like,
talking, please mute your mic. Thank you.
so we are going to be subtracting them according to their like terms. Like you subtract the ones with the I from A and from that of B. So if you're having the 4 minus 5, since they are both on I, subtract them, then you add it to the one for the plus sign is not totally like an addition, but it's just like to combine the directions together. So then you do the one for the J, same thing with the one for K. So the one for J will now be minus 2, minus 2. So you'll be having that. The one for K will be 5 minus 3. So those directions you now write the answers out.
There's an error, ma. It's supposed to be
Yeah,
minus 2 plus
Plus
2.
-2 plus
plus
2K.
2K.
Yeah,
Yes,
I've
plus
seen it.
2K.
Yeah. Thank you very much.
Excuse me, ma. What is that
Yes,
a
please.
question? I have a question.
Okay.
Ma, when we were doing the addition part, A plus B, we could interchange the values. We could interchange them. So with what is here, does it mean that A minus B and B minus A are going to be completely different values?
Exactly.
Okay.
Exactly. Just like 1 minus 2 is different from 2 minus 1.
Okay, ma.
You understand? But if it is plus, 1 plus 2 is the same thing as 2 plus 1.
Okay, ma.
Thank you very much. So we have laws of vector algebra. You can use any of the vectors that we've tried before to verify this law, play along with it. And I have some exercises that I want you to work with. Now, let's quickly look at multiplication of vector. I still have like 20 more minutes to round up. Multiplication of vectors. So we have different ways that we can have multiplication of vectors carried out. We can have a scalar multiplication of vector, whereby we use a scalar to multiply a vector. The operation of multiplying a vector by a scalar is called scalar multiplication. And it is like a scaling. You understand? If your vector is A equals to AI plus A1I plus, please mute your mic, plus A2J plus A3K, and your scalar is R. You want to find RA, then the scalar is going to multiply each of the vector components. That is RA1I plus RA2J plus RA3K. Okay? And for example, if my vector is R is equal to 2I minus 7J plus K, and I have a scalar value, which is 3, and I want to use the scalar value to multiply my R, it will just be 3 times each of the component. 3 times 2I, 6I. 3 times minus 7I minus 21, 3 times minus 7J, which will be minus 21J, and 3 times K, which is plus 3K. And that is that about scalar multiplication. We have 2 types of multiplication of vectors. We have scalar multiplication and we have vector multiplication. We have 2 types of vector multiplication. We have the dot product and we have the cross product. So for the dot product, the individual components of the 2 vectors are multiplied, just like this. If we have vector A and vector B, and we want to do dot multiplication, that is, you say A1 times B1 plus A2 times B2 plus A3 times B3. That is dot multiplication. Or you can also use this formula here. A dot B is equal to the magnitude of A times the magnitude of B times the cos of the angle between the 2 vectors. We'll look at an example now for us to understand what I'm trying to say. So like from here, from this that is being given, we can find from here the A dot B is equals to magnitude of A multiplied by magnitude of B cos theta. We can find the angle between them if we don't have it before. Okay, so let's look at this example. And we have property of scalar product. And one of the property is that A dot B is equals to B dot A, just like I told you before. 2 times 3 is the same thing as 3 times 2. Okay, and if you now do I dot I, that is the unit vector. The unit vector, if a unit vector is multiplying itself, it gives you 1. But if a unit vector I is multiplying a unit vector j, it gives you 0. And that is why when you were multiplying, it's as if we only multiply all the i's together, we multiply all the j's together, and we multiply all the k together, because when you say a1 times b1, whatever you get, you put it. Then I dot I will give you 1. That's why we don't write it. But if you say A1 times B2, you write it. Then I dot J is 0. So that is why we don't consider the other ones for dot multiplication. And that's why it looks as if we are looking at A1 dot B1 plus A2 dot B2 plus A3 dot B3. Then if A dot B is equals to 0 and more of the vector and none of the vector is 0, then it means that A and B are perpendicular vector. We are going to see something similar. And just like we saw, just like we saw when we are trying to find the x and y component of a vertical downward vector F3 in the previous example. So if we have A dot B is equals to 0, and it's not that A is 0 or B is 0, then it means that the two vectors are perpendicular to each other. So let's look at an example on dot product. We have A is equals to 2i plus 3j minus k, and B is equals to 6i minus 3j plus 2k. Remember, this is the formula that we have. We were asked to find the angle between them, because we want to find, if it is just multiplication that we want to do, we'll just say 2 times 6 plus 2 times minus 3 plus minus 1 times 2. We'll get an answer. But because we want to find the angle between them, we use this formula. So A dot B, we make A dot B is equals to the magnitude of A times the magnitude of B cos theta. And we make cos theta the subject of the formula, just like we did sometime. If you make cos theta the subject of the formula, that means we will find A dot B divided by the magnitude of A times the magnitude of B. So what is A dot B? A dot B is 2 times 6, which is 12, plus 2 times minus 3, which is minus 6, plus minus 1 times 2, which is minus 2. And that is what we have up there. Then we find the magnitude of A. What is the magnitude of A? Square root of 2 squared plus 2 squared plus minus 1 squared. What is that? Who can tell me the value of that quickly? What is the value of that? The magnitude of A. What is the value? 9. Thank you. And what is the magnitude of B?
7.
The magnitude of B. 6 squared.
7, ma.
7.
7. Thank you very much. So, then we'll now put it here. Remember, cos theta is equals to A dot B. What is the value for A dot B? That is 2 times 6 plus 2
4.
4. So we have 4 divided by root, or let's just put the value 3 times 7, which is 21. 4
Yes.
divided by 21. Whatever it is,
Zero.
gives us.
1905.
Then you now find cos.
0.1905.
Thank you very much. You now find the R cos of 0.1905, which is 79 degrees. Any question before we continue? Let me see what I can introduce, then we'll continue next week. Or let me quickly see where we can find ourselves in the next 15 minutes. So
Nice,
thank
yeah.
you very much. So let's
Alright.
try to round up. We have the
Okay.
next one.
Not to spoil. Not to spoil.
Please mute your mic if you are not talking to us. Thank you very much. So the next one is cross product. What can you notice about the dot product? The dot product will always give you a scalar quantity. You understand? But the cross product will always give you a vector quantity. How do you find the cross product? If your vector is A is equals to A1I plus A2J plus A3K, and B is equals to B1I plus B2J plus B3K, A cross B, this is the formula you are going to use, matrix form. You have IJK at the top, then A1 under the I, A2 under J, and A3 under K. Then for the B component, we have B1 under I, B2 under J, and B3 under K. So if we have a matrix, then we now find the determinant of the matrix. How do we do that? When you bring out this I is what we have here. So when you bring out the I, you cross the remaining one like this. You understand? Yes. So that you do A2 times B3 minus A3 times B2. Is that okay? You bring your I, the first one, and you do this A2 minus B3 minus this A3 times B2. That is for I. Then you now, and you should also have it in mind that there is a natural sign allocation or convention. We have the plus, minus,
Plus.
God bless you, naturally. So you now bring out minus J. When you bring out minus J, you have A1 times B3 minus A3 times B1, as you can see. This times this minus B times this. Okay? Then you now also bring out the K. When you bring out the K plus K, you cross it that way. So you have A1 times B2 minus A2 times B1. Is that okay? And
Yes, ma'am.
you get your values. So let's quickly look at an example. And we have some other things about the cross product. We have some other rules. A cross B is not the same thing as B cross A. Please note. We are going to, if time permits, we'll look at an example in that area. So, example, A cross B. We want to find A cross B. A cross B. So, A is minus 3I plus 2J minus K. And B is 2I plus J plus 3K. So, how do we do that? We have our IJK at default. Then we have A1 under minus 3, A2 under J, and minus 1 under K. You bring out the component, and the coefficient, and you put it under the respective unit vector. 2 under I, 1 under J, and 3 under K. So I want you to try to quickly solve. Okay, let me just explain this. I'm still coming to, I'll give you an example to solve now. So now, I brought out this I. Then, when I brought out the I, remember what happens? So I have 2 times 3 minus 1 times 1. So 2 times 3 is 6 minus 1 times 1. That is -1. So -1 times minus is plus. So that is why you have this. But let me first and foremost talk about this. So I have I 2 times 3 minus 1 times 1. That is for the first one. Then I also bring out minus j. When I bring out minus j, I have -3 times 3 minus -1 times 2. Then I bring out my k. When I bring out k, I have -3 times 1 times 2 times 2. So let's look at it. 6 minus 1, that is 6 plus 1, I. Then minus j. -3 times 3 is -9. Then minus, we have -1 times 2, -2 times minus, so plus 2. -9 plus 2. Then plus k. -3 times 1 -3. Then -2 times 2 -4. So by the time I bring it out, 6 plus 1 is 7i. -2 plus 2 is then times minus again. That is -7 times -j plus 7j. Then -3 -4, that is -7, -7k. So I want you to quickly do B cross A for me. Can you quickly do B cross A and tell me the answer so that we can compare the answer quickly? We have less than 8 minutes. Quickly.
7i plus
minus
7j minus 7k.
minus 7k plus
Can you
7k.
please tell me one after the other so that I will be able to hear you clearly? So B cross A is what?
Minus 7i minus 7j plus 7k.
Minus 7i minus 7j plus
7k.
7k. What can you say about this? Can anybody see anything?
It means that A cross B is equal to the negative of B cross A.
God
That
bless
the
you.
negative of the answer
You
of
have
A
said
cross
it
B.
all. You have said it all. You have said it all.
You are 20 much.
My guy said you are 100 much. Somebody is raising his hand. Okay, God bless you. You are all good. Let's continue. We are rounding up very soon. We are rounding up. You are all wonderful students. I want you to use what you have here to clap for yourself. Not physical clapping now, but clap electronically for yourself. So we also have an example which proves what we are trying to say, and you've already done it. So A cross B, we did another example, but you have also confirmed it, that A cross B cross A is equals to minus A cross B. Or you can say A cross B is equals to minus B cross A. It's the same thing. Moshood, you are raising up your hand. Give me a few minutes. Okay. Then we were also asked to show that A cross B is perpendicular to both A and B. So to do that, that means, remember, we said that two vectors are perpendicular if their dot product is equals to 0. Remember from the properties of vector that we talked about. So we already have A cross B to be this value, and A is this. By the time you do the dot multiplication and you add them together, you get a 0 for the first one. Then for the second one, B dot A cross B, this is B dot, we have A cross B. So by the time you do the dot multiplication, you also get a 0. So it
Ma,
means that A plus B is perpendicular to both A and B. Yes, please.
Ma, please, I didn't see the other slide. How you got the A?
This one has already been done before. You understand? Let me go back. This, we did this. We did A cross B. I did A cross B for you, and you did B cross A for me. You understand? And we saw that A cross B is minus B cross A. You understand? So I didn't bother doing that for this other example. Okay? But I just used the answer. They did A cross B. So if the answer of the A cross B is minus 3I plus 5J plus 11K. And B cross A is 3I minus 5J minus 11K. If you look at the two, it's in line with what we did earlier. So that A cross B is minus B cross A, okay? But in the question that we are solving, we were told to show that A cross B is perpendicular to both A and B. How do you do that? For any two vectors to be perpendicular, their dot products must be equals to 0. Okay, and that is what we just showed now. That A, we have vector A to be 2I minus j plus k, and we have A cross B to be minus 3I plus 5j plus 11k. So if you do the dot product of that, and you add them together, you get a 0. Can you see it? Then likewise, B dot A cross B. B is 3I plus 4j minus k, okay? And if you now dot multiply by minus 3I plus 5j plus 11k, you still get a 0. So that means A cross B is perpendicular to both A and B. Any question?
Yes, ma'am.
Okay. Can we hear you
Yes,
in
ma'am.
1
In the
minute?
other slide, that you gave, I saw that 7 was common within the 7I, J, and K. So I want to ask, this particular slide.
That can you bring it out, factorize?
Yes, sir. Factorize, yes.
Well, if they
Is there?
don't ask you to, there's no need. You
Okay,
can
so you
bring
just
it out, but there's no need, you understand? If you
okay.
bring it out, that means you now went into a scalar multiplication, you understand? But you don't need that.
Okay,
So you can just leave it the way it is.
okay, ma'am.
Okay. Any
Okay,
other
thank you.
question? Who else is raising his hand? Boluwatife,
Oh, yes, ma'am. Good morning, ma'am.
good morning.
So this is my question. You mentioned that two vectors are perpendicular to each other. So I want to ask, can they also be parallel to each other, or can we just have them perpendicularly?
No, like the reason why I raised that was part of the properties of vector. Okay, part of the properties
Okay.
of vector is that of dot product is that you can see if A dot B is 0 and none is this is none, not more. None of the vector is 0. If vector A is 0, for example, and I say A dot B, of course, it's automatically 0. But if the dot product of two vectors are 0, and it's not that any one of them is 0, then it means that that vector is perpendicular to the other one. You
Oh, okay,
understand?
ma'am.
So that
Okay,
is what
ma'am.
we are
Okay.
trying to prove.
All
Is
right,
that
then. Thank
okay?
you. Yes,
Okay.
ma'am.
So any other person? Yes, excellence. You'll be the last person that will answer your question today, because I
Okay,
know
ma'am.
another subject now, another course. Yeah.
When trying to find the angle between two vectors, we use the dot product, which is A dot B equals to magnitude of A times magnitude of B cos theta. Can we also use the cross product since there's also theta in the cross product?
No, this is the formula for cross product here. I'm coming. Okay, see the formula for cross product here. A cross B is equals to magnitude of A times magnitude of B sine theta.
Okay,
Okay,
ma'am. That leads to my
it's not
second
the same.
It's not the same thing.
It's not the same
Go and
thing.
try it and come and report it in the next class.
So my oga say you can try it and you can share with us
Your
what you find
experience.
out.
Sorry, ma. Sorry, ma.
Yes,
Ma,
please.
what of the raised to power n that you put there?
That is a normal vector. We've not got into that, so don't disturb your head.
We should just leave it.
It's a normal vector. You can read about it. Read about it because, like I said, I'm not going to be spoon feeding you with slide, with this, with that. Okay, I will introduce some things to you and we expect you to go and read more about it. So my first assignment, go and read more about this formula for A cross B is equals to magnitude A times magnitude B sin theta times normal vector. Read about it and we'll start from there next week. Any other
Ma,
question?
What about the slides now? The material says.
What?
Ma, the slide.
Don't worry,
Ma,
I
please,
will,
the
I will
slide.
give you the area to what the material to read. I won't share my slide with you anymore. Thank you. Or I can share some old
Ma,
slides.
please now.
Don't worry.
Ma,
Thank
please,
you.
Please.
Yeah,
Ma, please
wonderful
now.
student.
please,
Hello,
ma.
ma. Please, your
Love
next
you
class.
all and
Read
try
the
to
Thank you,
location.
ma.
Your next physical class, the location.
So the next physical class will be communicated. We'll be using the ELT and room 301. You can
Okay,
access
ma.
it. It's
God
still
bless you,
with
ma.
the engineering
God
faculty.
bless you, ma.
Thank you.
Okay, ma.
I
Thank
hope
you.
everyone has
Thank
a
you, ma.
good time.
I love you, ma.
God bless you.
Thank you,
Bye.
ma. Thank you, ma.